My name is Peter. Thank you for the introduction. I'll reiterate what Becky said. I've been to a lot of scientific conferences too, and this was by far the most exciting one I've been to in a long time. Amazing presentations. Well done, everyone. I work at the University of Oxford in the physics department. I finished my PhD a few months ago, but I was very lucky to be Becky's student when I was in sixth form, and I worked on some of the early stages of Lucid and CERN at school back in 2007. I was also very lucky to work with Professor Steve Rose, who is one of the key people in setting up Iris, and I was very fortunate in sixth form I was able to publish a scientific paper based on the project in sixth form. Not this paper, but one Becky showed earlier about plasma physics. So we've seen what amazing work those of you have done across the country today, and I think all of you deserve to loads of this work deserves to be published. People should be able to see what you've done. So this is just kind of a bit of a guidance of what we should be, I think we could be starting to think about in terms of CERN School for publishing things. So fundamentally, why do you do this? If you even if you have the most amazing research in the world, if it doesn't get communicated to other people, then people don't know about it and can't take advantage of it. If you come to some amazing new medical diagnosis technique or something, but it doesn't get communicated, it doesn't go anywhere. So there's many ways to communicate your research. One is things like today, symposiums and conferences. You've all done amazing work communicating things, because that's a skill in itself. Even if you've done great science, it's also very hard to work out what's the best way to communicate that. You've got to think about your audience. Another way of communicating your results is if you're talking to the public. As I'm sure you know, if you try to explain it to other people in your school, that's a very different form of communicating science to communicating to other scientists. There's writing things for magazines, there's newspapers and so on. But the main way that scientists communicate with other scientists is scientific papers in journals. So this is meant to be a permanent record of your scientific results. Other scientists should be able to look at these papers, see exactly what you've done, and if they want to, go ahead and reproduce it and see if they get the same results as you. So permanent record of your findings. This isn't to be underestimated. A lot of the projects that you've been working on, you'll find that maybe in 50 years' time, someone's interested in what the radiation was like in the oceans in the 2010s. They can't do a time machine and go back and do that. They'd have to look in your scientific paper and see, what measurements did they make back then? So it's vital that you record these things so that people in the future can reconstruct this. And ultimately, this is also a way for you to get credit for the amazing work you've done. You can say, this is something solid, this is some thing that I've discovered that people didn't know before. So papers are normally published in journals. These used to be big, thick publications. Now it's mainly online. This ranges from journals called Science and Nature, which are like the most famous journals, and they cover all science, to really specific journals. So I've just put one there, Journal of Nuclear Medicine and Radiation Therapy. Typically what happens is you write a paper, you submit it to the journal, they then pass it on to someone else who works in that field somewhere in the world, normally anonymously, and then that person then says, yep, that's great, we'll publish that. No, we don't think that's sufficiently new, or we think there's a problem with it. Or more likely, they say, yes, this is good, but you probably need to change this aspect of it before we think it's a suitable standard for publication. And then you make those changes and you send it back to them, and then they say yes, or they say no, change a bit more, and maybe you go forwards and backwards a few times, and hopefully it gets published. So what do these papers look like? Typically it's around 7 to 20 pages, so they're not huge documents. I'm sure you've all written reports and EPQs and so on that are around this size. You should have to have all the figures. You've all got loads of great graphs in your project, so you've already got a lot of this work, so only a small amount of work to convert this into something publishable. Papers should always be something new that wasn't known before, but that doesn't have to be, oh my god, I've discovered the Higgs boson. It can be, I've confirmed this known existing effect, but I've just measured it in a different way, or I've used a different analysis tool, or I've used a different technology to measure this thing. So all of you have been doing new things. Don't feel that you have to have discovered some new particle or something. You've all been doing measurements that weren't made before in a different way, so it's all novel stuff. how do you actually format these things? So punchy title, obviously, to kind of draw people in. You have an abstract, which is essentially a summary that's basically just one paragraph. Often people will just kind of read the abstract to kind of see whether they want to read the rest of the paper. You then kind of have an introduction, which is kind of setting the scene, why we're interested in this problem. So you all had that in your presentations. You kind of had a bit to introduce the idea of primary and secondary particles, explain the idea that we're interested because we want to be able to protect astronauts going to Mars and so on. So that a reader who wasn't familiar with cosmic rays or whatever your project's about can find out what that is. You then want to describe your instrumentation. So in this case, it would be describing what a metapix is, describing we had it set up in this way, maybe it's describing exactly the setup of Lucid or similar. You want to describe a methodology, so that's maybe describing the TAPIS platform, or it's describing what statistics you use to analyse your results. Then you kind of have a results section, which is just the kind of bare facts. We measured this much radiation at this time, X, Y, Z, indisputable facts. And then you kind of have a discussion section, which says, because of this, we think that this theory is more likely, or we measure this, therefore it's going to be quite hard to go to Mars, or something like that. And then finally you should conclude it. And all the way throughout you have to be kind of comparing and discussing it in comparison with what other people have done. So maybe you measure 5 millisieverts using Lucid, find what other cosmic ray detectors have measured and say, well, we got more or less than them. Do we know why that is? So just kind of conclude. This is something hard to do. It's kind of requires a lot of reading other papers and putting it all together. But it's rewarding to kind of that made a permanent contribution to human knowledge. I think it's something that Iris and CERN School should be working towards. In my opinion, a kind of logical way to split that up would be to kind of try and come up with one paper which kind of describes the kind of space side of things, TIMPIX and Lucid, and then kind of one paper kind of with the ground-based stuff, the kind of soil project, Ray, and all the other kind of metapix measurements, CERN and C that we've been making, and to try and come up with, over the kind of coming year or two, kind of 2 papers that kind of summarise all the amazing results that people across the country have been making. So I'm going to be talking to some of the schools in the coming months about trying to put that together, so do contact me or Becky Parker if you want to contribute to that. I think that's it.
Fantastic.